Hello everyone, this is Manshi and I am going to explain you the topic that is dimension. As we are going to understand it as a mathematics topic, we are not going to look for the quantum part. Basically, what is dimension? Dimension is something that we can understand in terms of size and position. Basically, there are four types of dimension. First one is zero dimension, then the first dimension, then second dimension, then third dimension. There are many more dimensions also, but as it's a controversial topic, we are not going to look for that. Let's see what does first, second, third and zero dimension means actually. Before going to zeroth dimension, we will first have to understand about zero. What is zero? Zero is something that has nothing. Here, similarly, the zeroth dimension is something that has no magnitude at all. And thus, we consider a point to be a zero dimension object. Why? Because when we draw a point on the surface, something like this, then from our naked eyes, we cannot measure its length, breadth and height, showing that it has no magnitude at all. Thus, since a point has no magnitude at all, that's why we consider it as a zero dimension object. What will happen if we will combine lots of points together like this? We are seeing over here that after combining lots of points together, or we can say that after combining lots of zero dimensions together, we are getting a straight line, something like this. And we all know that we can measure the length of the line, showing that it has one measurement unit, that is length. That's why we consider a line to be in first dimension. What will happen if we will combine lots of lines together? We are seeing over here that after combining lots of lines together, we are getting a plane. A plane is nothing but a flat surface. Anything which is flat comes under the category of second dimension. Here we are seeing that the plane is taking the shape of the rectangle, and we all know that a rectangle has length as well as breadth. Any object, anything that is flat like square, circle, rectangle or triangle, anything that is flat comes under the category of second dimension. Similarly, what will happen if we will combine lots of planes all together? Here we are seeing that after combining lots of planes all together, we are getting a solid structure, and this structure is nothing but cuboid. We all have studied that the cuboid has length, breadth and height. Since it has three dimensions, or we can say that it has three measurement units, that is length, breadth and height, that's why a cuboid comes under the category of third dimension objects. Other examples of third dimensions objects are cube, cuboid, sphere, cone, octahedron and many more. Anything that we see in our real life that we can touch and feel comes under the category of third dimension objects. As you all have understood what does dimension means and what are the types of dimensions, let's go forward and see what are the real life examples of the dimensions. The example of the zero dimension is nothing but star. When we see a star from Earth, it looks like a dot object. We can say that a star is a zero dimension object. Similarly, if we will take a thread in our hand, that thread is nothing but a straight line. We can say that that thread is example of first dimension object. Now what is the example of second dimension object? Sheet of paper. A sheet of paper has length as well as breadth. It looks like a rectangle, it has nothing but magnitude. And since it has magnitude as well as two measurement units, that's why a sheet of paper is an example of second dimension object. Moving forward, we will see some examples of the 3D object. The best example of three-dimensional object is nothing but a cuboid. As you can see over here, this cuboid has length, has breadth and has height. Since it has three measurement units and obviously it has some magnitude, that's why the best example of a three-dimensional object is nothing but a cuboid. Now, I have a question for you all. Can we say that dimension is nothing but a perceptual topic? What do you think? Tell us in the comment section. Now, according to me, I think that dimension is a perceptual topic. Why? Because when we see a star from Earth, we find out that it looks like a point object. That means it's in 0 dimension. But in actual, we all know that a star is a huge celestial body that is very very far away from us. That means it's a 3D object in reality. But because of the distance between the earth and the star, that 3D object is looking like a point object. That means it depends upon our perspective, from what angle, from what distance we are seeing that object. It matters a lot to describe their dimension. So now let's take another example. Let's suppose if I keep this cuboid like this. So whether this cuboid is looking like a cuboid to you or just a rectangle? Tell me in the comment box. So this all confusion was because of the change in the position of that object. Because when we start to move that cuboid, we see that it's a 3D object. But when we keep it at a particular point, we have seen that the cuboid was looking like just a rectangle. So it was because of the position. And the other terms was size. Why does size matter so much for the dimension? It is because when the point object gets expanded, or we can say that the one dimension object like a line gets expanded, we see a larger version of that, and we can easily measure their length and breadth. Similarly, if we will bring the star from space to near our earth, we will see that the star is not looking like a point object now. It's looking like a huge celestial body. So we can say that because of their size, that has changed because of our perspective has mattered a lot to change their dimension or to explain their dimension. Now I hope that you all have understand why does size and position matter so much for an object to explain its dimension. So now move to the next topic that will be explained by my friend Vedangee, that what is perfect and imperfect shapes. Thank you.
Hello everyone, myself Vedangee Patkar and I am a FYBSc student. I am from the group Illusionist. So my friend Manshi has explained you some different concepts related to dimensions, like what is a dimension, what are different types of dimensions, and how we move from one dimension to the other dimension. So what we are going to discuss is some theories or some concepts related to the shapes of 3D objects. So whether a 3D object is imperfect or perfect. So let us discuss. So first let us see what is a perfect 3D object. As a person has different kinds of names, a perfect 3D object is also said to be platonic solid. Solid obviously because we are dealing with the object which is solid in state, and the second platonic. So platonic or perfect basically means an object satisfying 3 basic conditions. The first condition is that it should be made up of 2D objects which are congruent and regular. The second condition is each vertex of the object should have equal number of faces converging. And the third condition is the angles at the vertex should have an addition which is less than 360 degree. So quite confusing, don't worry, we'll see with an example. So the first example is a cube. As we all know, a cube is a 3D object made up of 2D object square. Now if you see a square, it is regular because it has same size and same angles. As you see a cube, it is made up of squares which are of equal size, hence it is congruent. Hence the first condition is satisfied, that is nothing but congruent and regular. The second condition was each vertex should have equal number of faces converging. So let us see. If you see this vertex, here 3 squares converge, that is 3 faces are converging. I'll take some other vertex. If I take this vertex, at this vertex also there are 3 squares or 3 faces which are converging. Hence, the second condition is also satisfied. Now, the third condition was the addition of angles at the vertex should be less than 360 degree. So, if I add 90 plus 90 plus 90, it gives me 270 degree, which is less than 360 degree. Hence, we have proved that cube is nothing but a platonic solid. Okay, so the second example is an octahedron. Okay, you can see it. So an octahedron is a 3D object made from 2D object triangles. We use 8 triangles to make an octahedron. Now, if you see this octahedron, or any other octahedron is made up of regular triangles. So regular triangle is nothing but an equilateral triangle having same sides and same angles. And also these triangles are congruent to each other. Hence the first condition is satisfied. Now I consider this vertex. You can see there are 4 triangles converging, or rather 4 faces converging. If I take other vertex, this, then there are also 4 triangles or 4 faces converging. Hence, the second condition is also satisfied. The third condition, if you add these angles at the vertex, that is 60 plus 60 plus 60 plus 60, gives you 240 degree, which is less than 360 degree. So, we have proved that octahedron is also an example of platinoid solids. So, till now we have seen 5 examples of platonic solids. Now let me tell you one interesting fact. The only possible 3D objects which can be platonic solids are only 5, and we have discussed them before. Any other 3D object cannot be a platonic solid, or rather a perfect 3D object, because it does not satisfy either of those 3 conditions, and hence they are said to be imperfect 3D object. So the first example is a cuboid. If you see a cuboid, it is made out of rectangles, and a rectangle is an irregular quadrilateral having unequal sides. And also, if you see, a cuboid is not made out of congruent rectangles. Hence, here itself, the first condition is unsatisfied, and hence a cuboid is said to be an imperfect 3D object. Okay, now the second example of imperfect 3D object is a sphere. Now, if you see the sphere, it is made up of squares and triangles. As you see, these triangles are not congruent to each other, and even they are not regular, which means the first condition for platinoid solids or perfect 3D object is unsatisfied. This shows us that sphere is a 3D object which is imperfect. So till now we have discussed 2 examples of imperfect 3D objects and 5 examples of platinoid solids or perfect 3D objects. Now I want to tell you some amazing facts about the sphere. I have shown you this sphere, right? If you observe it minutely, you will get that there are some ridges on the surface of the sphere. What difference does it make? It makes a great difference. It affects the radius of the sphere. Let me tell you how. What is the radius of the sphere? Is its distance from the center of the sphere to a certain point on the surface of the sphere. So when I measure the radius of the sphere, at this point, I get it to be 10 centimeter. At some other point, I get it to be 9.9 centimeter. At the certain point, I get it to be 10.1 centimeter. So, what we see that the radius of the sphere goes on changing. Now, what is the real life example of a sphere? The Earth, right? This we have been learning from our childhood that the Earth is spherical in shape. So, when we see that a sphere is an imperfect 3D object and having ridges on its surface, that means the radius of the Earth should also go on varying, right? And what we do while calculations is that we assume the radius of the Earth to be 6,400 km. But that's an approximation, my friend, because there are 2 reasons. First, Earth is a sphere, right? So it will have ridges and that will affect the radius. The second thing and interesting about Earth is that it is bulged out at the equator and flattened at the poles. That affects the radius. Yes, because at the equator the radius is greater as compared to the poles. This shows us that the concept based on the radius of the Earth are an approximation. So finally we have come to an end of our project. In this project, what we have seen was what are dimensions, what are different types of dimensions, how we vary from the dimensions, and what are perfect and imperfect 3D objects. The main aim of taking this as a project was we wanted to introduce you with the concept of dimension. Knowing dimension helps you to see your observational world better and helps in solving your daily life problems. Knowing dimensions can help you become a great problem solver. So, I hope you have understood whatever we have been trying to explain you throughout this process. And I know there might be questions in your mind. Don't worry. You can comment down your questions in the comment section, or if you want to ask us personally some questions related to the project or dimensions, you are free to ask. Our email IDs are down in the description box below. I hope this brings a great change in your life, and that's all. Thank you.